Okay, the next concept we're going to go over is the complete ionization problems. So, complete ionization, let's jump here for a sec. Ionization is the loss of H plus, which occurs in stages. Okay, so now going back up to here, we can see that this is monoprotic, meaning mono, it only has one H plus to donate. So when the reaction happens, it's going to just lose that one and then have this left over, okay? But because it says that it occurs in stages, these diprotic and triprotic that have 2 and 3 H pluses, they're only going to lose them one at a time. So first off, this would go down to like an HSO4 minus, and then another reaction would have to take place, and then it would go down to just SO4. All right, so I'm going to go over this process with you. The big takeaways for this slide is just that being able to identify monoprotic versus diprotic versus triprotic. Again, mono is just one H, diprotic would be 2, and then triprotic would be 3, and that's what we would see here. Okay, next slide. So let's talk about sulfuric acid. So we know ic is related to ATE, so this is going to be sulfate, all right? We know sulfate is SO4 minus 2, all right? And then from sulfate, if we want to make this an acid, we have to add some H's to it. And each H is plus 1, right? So we know we're going to have H2SO4, and that gets rid of the charge there. Okay, so to show the complete ionization of sulfuric acid, we're going to start with H2SO4, and we're going to do this in water, because water is pretty much everywhere, right? All right, so the next question is sulfuric acid a strong acid? All right, here are the strong acids. Remember? Sulfuric acid is a strong acid. Okay, so it's a strong acid, which means we do a single-headed arrow, and it's going to lose one of its H pluses. So it's going to go down to HSO4. Now, because it lost an H plus, you have a negative left over, all right? And where did that H plus go? It went to the H2O, so this becomes H3O plus, all right? And that's our first step for this, okay? The next step is taking the HSO4 minus, that's going to go over here, and a common misconception is to also take the H3O that's over here. You're not going to do this. If we're doing this, just think of it. It's in a beaker. There's a ton of water in there, and there's a small amount of the acid. So the acid is just going to grab another water molecule. All right, so this HSO4 minus, it's going to just find another water molecule, and then it's going to have a reaction. Now, is this a strong acid? No, it's not one of the 7 we memorized. So that means that this step is reversible. So you need the double-headed arrows. And then the same thing's going to happen here. This is going to lose an H plus. So then it's just going to be SO4. It lost another H plus. So now it becomes minus 2. So it's our sulfate. And then what forms that H2O that we had, it's going to get an H plus, and then you're going to get another H3O plus. So that's going to be the complete ionization of sulfuric acid. Now, overall, what is the product going to be? Like, what's going to be in the beaker after this reaction takes place? So after this reaction takes place, you're still going to have water because there's just a ton of water in there, okay? You're also going to have some of the HSO4, and then you're also going to have some of this SO4 minus 2 as well, all right? You're also going to have some H3O. So you're going to have some H3O. So you're going to have all of these products, everything that's over here on the product side, you're going to have in your beaker. The one thing we're definitely not going to see is any of this, because it always completely ionizes because it's a strong acid. All right. Now later on we can figure out like how much of each of these things are in here, but that becomes an equilibrium problem, which we're not going to do right now. Okay. There is another ionization problem on the next slide here. It's hydrophosphoric acid. What I'd like you to try to do is, one, figure out the nomenclature for it. All right, what is it? And then two, actually answer the problem. All right, show all the steps of ionization. Try that first and then go to the next video to find the answer.